So when we want to graph rational functions, we need to find all the asymptotes, vertical asymptote, horizontal asymptotes. We also need to find the domain of the function. This is important. The intercepts, okay? And once you have all of this information, then we start producing a picture. So let's do some examples to see how to do that. So I guess let me give you some general steps. So general steps to sketch rational functions. Okay, so the first thing that you want to do is find the domain. Okay, so let's say that you have a function y equal f of x. So the first thing that you do is actually, the first thing is to factor everything. So factor the top and bottom. But don't simplify, not yet. Okay? Then once you factor, then it's very easy to answer a bunch of questions. Like for example, it's very easy to answer the domain. So find the domain. It's also very easy to find the intercepts. So find the intercepts. Find the intercepts. Then after that, simplify and determine if there are holes. Remember, how do you know where you're gonna, who can tell me, how do you know if you're going to have a hole on the graph? How do you know?
If you have the same factor on the top and bottom.
Okay, be careful the way you're saying that. For example, do we have a hole for this function? So you see, x plus 3 shows up both on top and bottom. But the thing is that when you simplify, it remains in the bottom, right? So remember, you're going to have a hole if a factor that's on top also shows up in the bottom, but then after simplifying, it disappears from the bottom. If it's no longer on the bottom, then you have a hole. If it stays in the bottom, you're going to have a vertical aspect. Okay? So after you simplify, you observe is if a factor disappears from the bottom, you have a hole, make a note of it. Otherwise, you're going to forget, you're going to draw the wrong picture. If you don't draw the hole, it's wrong. Okay? All right. So simplify and determine if there are holes. So you find those. So at this point, we already have our function simplified. So now we find the asymptotes. So find vertical asymptote and horizontal asymptote. So remember, vertical asymptote is just the zeros at the bottom here, because you already have something simplified. You just look at the zeros at the bottom, whatever remains in the denominator. Okay, and here you look at degrees to determine. And then after this, with all of this information, you sketch. Okay. So I guess let me be a little bit more precise in the following respect. When you find the asymptotes, okay, you also need to keep in mind the behavior. Okay, once you know an asymptote, then how do you know how the function behaves around the asymptote? So for example, if we have, let's say that we have a vertical asymptote like this. You need to understand that that means that when you're graphing, there are 4 possibilities for the function. So to the right, it can go like this, or this way, one of these two, right? And to the left, it's either this way or this way, okay? So how do you figure this out? You start, testing the sign of the function. On the right, you pick numbers that are close here, and then if you get positive values, that means the function goes up, right? If you get negative, it means it goes down. Remember, it's one of the two, it's not both. Otherwise, it's not a function, okay? You do the same thing to the left. Now, when you have a horizontal asymptote, that means that your horizontal asymptote is going to look like this. So once again, you have 4 possibilities, but then the choices are like this, or like this, like this, or ladies. Okay? So you are either above or below the line. To really spot this, you will need to do an inequality. But typically, when you get to this point, the graph will tell you what's going to happen. Okay? The graph really is going to tell you whether it should be above or below the line. Okay? But in the next section, we're going to talk about non-rational inequalities. And when you put inequalities together, then you'll be able to formalize this more precisely. Okay? This is a little bit more difficult to figure out than this one. Because this is just plugging points. Here, you have to, if you want to be formal, you need to do some more stuff. Okay, so let's do examples. So sketch, and let's see. Let's sketch the one that we saw before. Let's do this one, and then I'm gonna give you two more for you to try. Okay, f of x equals x plus 2 over x squared minus 4. Again, the first thing that we do is we factor everything. This is the one that we have been studying from the beginning. Because by doing this, we can very easily now find information that we need. For example, domain. What's the domain of the function? Yes?
Negative infinity to negative 2 union.
So we need to skip negative 2 and 2. Right? It's all real numbers except 2 and 2. So the domain will be all of this. If you want, you can write it down as interval notation. But remember, these are just little steps that we're doing that will allow us to graph later. So, if you draw the picture, unless I ask you specifically for the domain, if you just draw this picture, then that's good enough. Okay? This is for you to know. For example, this tells me what? That potentially we're going to have at most 3 pieces for the graph, right? 1 piece over here, 1 piece over here, 1 piece over here. And say potentially because if there is a hole, then maybe you may count that piece with the hole as 1 piece. Okay? Okay, so the function is not defined at these 2 points. That means that, for example, your candidates for holes and vertical asymptotes are these 2 guys. If we're going to have any vertical asymptote hole, they have to happen here. Okay? So we get there soon. So next, I'm going to find the intercepts. So let's find the intercepts. And remember, this means y-intercept and x-intercept. Now, how do we find the y-intercept of a function? How do we find it? Just plug in 0. So f of 0, what do we get? 2 over negative 4, which is negative 1/2. So that means the y-intercept is the point 0, negative 1/2. That's 1 point that's going to be on our graph, okay? We do a blue box because 1/2 points. Now, x-intercept, remember, for this, you need to solve the equation f of x equals 0. You need to make y equals 0. Now, when you have a fraction is 0 only when the top is 0. That's why I asked you to factor top and bottom, because then it's very easy to read off this information. Just look at the top. When is the top 0? So a fraction is 0 only when the top is 0. So I give you negative 2. Do you understand this? Now here you have to be careful. Because here you may think, oh, x equals negative 2 is an x-intercept. Well, remember that negative 2 was a value that's not good for us. So are we really going to have an x-intercept? We don't have an x-intercept. Does that make sense? So, but this is not in the domain. Since the domain precisely skips negative 2 and 2, it's not in the domain, so no x-intercept. So we are not supposed to cross the x-axis, okay? And we have a y-intercept. Okay, so we have a domain, we have our intercept. Then what will be the next step? Now we're going to simplify, okay? So we have our function f, which is x plus 2 over x plus 2, x minus 2. Then I'm going to simplify, and we get 1 over x minus 2. Now, I'm going to use a different color, because technically speaking, this function is not the same as our function, okay? The only difference is that our function, the graph of our function will look just like this one, It's just that our function is gonna have a hole. Where? What is it? Say it louder. So x equals -2. Okay? So our function is going to have a hole at x equals -2, while this one doesn't have any hole. Okay? So, but essentially, the graph of our function is just like this guy. So right here, we can immediately say, okay, I notice that it's going to be a hole, and the hole is going to be a -2, comma, what's the y value for the hole? How do you find the y value of the hole? -1/4. Very good. You plug it into a simplified version. Okay? You plug it into a simplified version to get the y. So we already found 2 points that are important for a graph: the y-intercept and then the hole. Any questions? Okay. So now we're going to be working with the simplified version from now on. Okay. So asymptotes. So let's see. Vertical asymptotes. Do we have any vertical asymptote? What is it?
2.
X equal 2. I encourage you to really engage in this because you have a test on this after tomorrow. Okay? So it's in your best interest to be engaged in this. So x equal 2. Do we have any horizontal asymptote? Yes, we do. The value of the top is less than the bottom. So as a line y equals 0. Okay? Which is the x-axis. All right. So let's attempt to graph this. And then you will see that we will need to pick more points, but let's get the graph started. I mean, if you want to have a little bit more accuracy, we may need to pick more points. Okay, so when you're gonna graph, my advice is draw the asymptotes first. So let's see, we're gonna have the horizontal asymptote y equals 0. Okay, that's already the x-axis, so it's there. And then the vertical asymptote, which is the line x equal 2. So let's see, let me declare that because of the nature of the points, I'm gonna have, let's say that this is a 1 here, this is gonna be 2, so then more or less this is a 1, this is a 2. And then the asymptotes, we typically do them as dashed lines. Okay? Okay, so we have our horizontal asymptote, which happens to be the x-axis, our vertical asymptote, which is the line x equal 2. So next, plug all the points that you found. So the intercept, we found 0, -1/2. So if this is -1, then here is -1/2. So right here is my intercept. I'm not doing blue. Okay, and then we also have the hole, which is -2, -1/4. So let's say this is 1, this is -2, and then here is -1/4. That's a hole, so I'm going to do a little hole in it. Okay, because it's a hole. Okay, so these are the points that we have. Now we're gonna, if we need to find more points, we will. So next, what we're gonna do is we're gonna find the behavior of the function around each of the asymptotes. So let's talk about the vertical asymptote first. Let me put 3 here. So remember, the original function is f of x, which is x plus 2 over x plus 2 times x minus 2. And for this, if you want, you can always look at the simplified version, which is easy. As long as x is different than -2, the equality holds, so might as well use it. Okay, so we want to figure out the behavior around the vertical asymptote. Let's just say right, and then we look at it from the left. So from the right, there are 2 choices. We either do this or we do this. Okay? We either go up or down. Which one of the 2 is it? How do you determine this? Pick a point very close to it. Okay? So pick a point that's close to 2. Like 2.1 or whatever you want. Okay? As long as it is on over here. Just put it in the function. This one is easier to work with. If you put a number here that's bigger than 2, you're gonna get a positive, right? So 1 over positive, so positive over positive is positive, so you are up here. You understand this? Now, it's easier if you actually pick an actual point and plug it in, because that way you'll have more points. Because notice that here we don't have any points, so we don't really know the exact shape of the graph. So for example, picking like 2.5 may be a good idea. If I pick 2.5, I get 0.5, right? In this difference, which is 1/2, so the output here is 2, right? So let's see. I'm gonna have my little table of values. This is like a strategic table of values, if you will. Okay, so I'm gonna record the values that we already have, just for completeness. And then let me say the type of point that it is. For example, we have 0, -1/2, and this was the y-intercept. We also had the point -2, -1/4. That's a whole. Now, strategically, I'm going to pick 2.5, and the y value is a 2, right? Because it's 1/1/2, and this is just a test point. And that's going to do is that's 5/2, and then that's going to give me 2. So this tells me that I have to go to this point. So then, when you are to the right, we're going up. Okay? We need to go to this gap. Now, let's go to the left and repeat. For example, I'm going to pick 1.5. So it will be 3/2. Okay? So if I put 1.5 in here, I'm going to have -0.5, yes, which is -1/2, and then 1/-1/2 is -2. So if I put 1.5, I get a -2. This is another test point. So that means that it's going to be down here. So that means, you know, the choices were this or this one. So we either go up or down. Because we're down here to the left, then it has to go down to -infinity. Do you understand this? And you can also reason through it. If x is less than 2, this quantity is negative, positive divided by negative is negative. So we are down here. Okay, so this already tells you what's the behavior around the vertical asymptote. Now let's do the same thing around the horizontal asymptote, and then we're ready to graph. I mean, at this point, probably you can already guess what the graph is going to be, but let's do it. So let's see, horizontal asymptote. Let's look at what happens at positive infinity. So again, it's either this or this. So which one is it? Well, rational functions are not continuous. Remember, continuous function is a function that you can draw without lifting your pencil. However, it has several pieces, each of which are almost continuous. What do you mean by almost continuous? There could be holes. Okay? But if you don't have a vertical asymptote, that means that you should be able to draw the picture without lifting your pencil, with the exception of some potential holes. Okay? In particular, we found already all the x-intercepts for the function. In fact, our function doesn't have an x-intercept. Okay? So on this side, we know that we need to have graph over here because here is a point, here is this behavior. We need to get close to this line, either like this or like this one. Okay? There is no horizontal, there is no vertical asymptote happening over here. There is no x-intercept anymore. So that means that our graph has to stay above the x-axis all the time. Because otherwise, you will need to go through the x and create an x-intercept by continuing. You understand what I'm saying? So if you're already up here, there is no more crossing happening. So this is the end behavior. Okay? And once again, you can also reason about it. If x is extremely positive, going to positive infinity, the denominator here is positive. So positive divided by positive is positive. Okay? So you have to stay above the x-axis. So by doing this, you can already see, hopefully, that you know there is only really one reasonable thing to do, which is something like this. Okay? All right. So now let's go to this side and repeat. Again, at negative infinity, we have these two choices. It's either above or below the x-axis. If you see everything that's going on, we have a bunch of points down here, right? So we need to go to these 2 points. This is a hole, and then there is no more intercepts happening. There is no more vertical asymptotes going on. So we have no choice than to stay below. And also, if you think about it, when x is extremely negative, this bottom here is going to be negative, and positive divided by negative is negative. Okay? So this is what you get, and now it should be clear what's going to happen. So we have is sort of behave. Let's see. Go to this guy, my y-intercept, to this point, and then down to negative infinity. And here we get close to the x-axis from below. Okay, questions? So here we have one vertical asymptote, we have a hole right here. Remember, you always need to put the coordinates of the point. If it's not clear, then just do a little arrow and tell me the coordinate of the point. The intercepts that show up, you need to show them, right? All the necessary information has to be there. Okay, questions? All right, so let's see, why don't you try this one on your own? How about f of x equals 2x squared over x squared minus 4. Grab this one. Let's see, can we factor this? How do we factor this?
On the bottom, you make it x plus 2, x minus 2.
Okay, so x plus 2, x minus 2. What's the domain?
Negative 8 to negative 2, and negative 2 to 2, and 2 to 1.
So again, skip 2 and negative 2, right? So we skip 2 and negative 2. So x cannot be negative 2 or 2. Good. What are the intercepts? Do we have any x-intercept?
No.
Yes, we do. X equals 0. So remember, here you need to solve f of x equal to 0. A fraction is 0 whenever the top is 0. That happens here at 0. So that means the point 0, 0 is an x-intercept. Okay. Do we have any y-intercept?
0.
0, 0. So the point 0, 0, which is the same that we found, is both x and y intercept. Of course, that's the only point that's both on the x and y axis. Okay. All right. We have our intercepts. So now we're gonna find. Now we simplify. So is there anything to simplify here? There is nothing to cancel, so we keep working with the full function. Okay, asymptotes. Let's see, do we have any vertical asymptote? Do we have vertical asymptotes? What are they? So x equals, remember, you cannot tell me a number, you need to give me an equation of a line. X equals negative 2, x equals 2. Good. Do we have any horizontal asymptote? What do you need to do to look at, to find? Yes? So what is it? Y equals 2. Good. So for horizontal asymptote, you have to look at degrees. Here the degrees are the same, so there is horizontal asymptote and it's the ratio of the leading coefficients. Okay? 2 over 1, which in this case is 2. Y equals 2. Okay, perfect. So that's it. So now let's sketch. And again, as we sketch, we may need to plot a couple more points, okay, to get a sense of what the graph is doing. Let's see, x, y. Let me see, my function is there. Okay, so let's put the asymptote. So x equals 2 and negative 2. So let's see, 1, 2. Let's say this is 1, this is 2. 1. Okay, so we have two vertical asymptotes. Okay, so we have our x and y intercept is actually the same point, the point 0, 0. So we need to go through the origin right here. Okay. Now we also have a horizontal asymptote, which is y equals 2. Okay. And now let's start figuring out behavior around the asymptote. So we just take this one at a time. So let's see, vertical asymptote, let's look at x equal 2. To the right, it's either here or here. And, let's start making a little table. That way, we have more points to work with. So let's see, I'm gonna put my table here. x, y, and then the type. Let's see, we found the point 0, 0. This was x-intercept and y-intercept, okay? And that's it. There are no holes, okay? So we didn't find any holes, so no holes. So now let's find one more point. So let's see, over here, let's take a point to the right of 2. Let's say 3. If we plug in 3, what's y? So it's going to be a 9, right? So it's 18. So, and then what is this? This is going to be 5 times 2, so 18 over 10. No, 18 over, so 18 over 5, because this is going to be 1. So 18 over 5. 18 over 5. The point is that it's positive, and what's 18 over 5? That's 3 point something, right? So let's say somewhere in here. 18 over 5. Okay, so you gotta go through this point. So this tells me that to the right of 2, the function is up here, so it has to be this behavior. Do you understand this? If you want to be super sure, then just do a sign analysis. So you want to know whether the function will be positive or negative to determine where we really go up or down. So if you pick x bigger than 2, the top is always positive. This one is positive and this one is positive. So everything is positive. Okay? So it has to be the top. Okay. Now let's go to the left. Again, it's either this or this. I don't know. Let's pick 1. When x is 1, what is y? 2 over, so this will be a 3 and this is a negative 1. So 2 over negative 3. So negative 2 over 3. Yes? So negative 2/3. That's going to be here. Okay? So right here. And then that means that because we are below the x-axis, it should be going down here. Anyways, you can also test it. If x is less than 2, the top is positive. This parenthesis is still positive. Remember, we're close to 2, but less than 2. It's still positive, and now this one is negative. Right? Think about 1.9. Okay? This is negative. So positive, positive, negative, the whole thing is negative. So it's the behavior down there. So we get rid of this one. So we already know what happens around this one. Now let's go to this one and repeat. At this point, you can probably start guessing what's going to happen. But again, it's good to have more points. So I'm going to pick -1 here, just to see what's going on. I mean, the hope is that hopefully it's this one because of the shape that this is looking. But anyways, let's plug in -1. What happens if we put -1? Actually, there was something that I didn't tell you, but it's always helpful when you're graphing. You should look for symmetry. If the function is symmetric, then you will get a bunch of points for free. For example, this function is this symmetric. Notice that this is an even function. If you plug in -x, the only x that show up, they are squared. So when you plug in -x, the negative is gone, right? So that's a very nice observation that this is an even function because f of -x equals f of x. So that means that we get a bunch of points for free. For example, since we know that 1, -2 over 3 is on the graph, then if I plug in -1, then I have to get -2 over 3 as well. So, yeah, okay. So it's not that one, okay? So it's over there. So good, right? So remember, being even means that no matter if you change the sign of the input, the output stays the same, right? F of -x equals f of x. So if you plug in -1, you get -2 over 3. And also, so this is test point. And also because we know that 3, 18 over 5 is on the graph, then we get for free -3, 18 over 5 is also on the graph. Okay? So let's put our points, -1, -2 over 3. Go right here. Okay, and then -3, 18 over 5. All right, so now we can decide. So let's see. To the right of -2, is it this one? Is it the top or the bottom? Which one do you think it is? It has to be the bottom. We are down here, okay? And also by symmetry, if the y-axis has to be a mirror. So whatever happens to the right has to happen to the left. So if it's going down over here, that reflects down here, okay? So get rid of that one. And then similarly, because by symmetry, on this side, because here we're going to the right over here, to the right of this line, we're going up, then to the left of this one, which is the symmetric version, it has to go up as well, okay? And also notice that we have to point over here. So we have to have this behavior. Do you understand this? Okay. That's behavior around vertical asymptotes. Now let's look at horizontal asymptote. Again, either this one or this one. Which one of the two do you think it is? The top or the bottom? I mean, what makes sense is to say that it's the top. Technically, you need to make sure that we're not going to cross the horizontal asymptote, but then you need to solve an equation. So we're going to do it now. But in general, that's not going to happen. So if we are already up here, what makes sense is that we should continue this way. But it could be that it actually crosses and then come back down and gets close like this from below. You have to figure that out, whether that's going to happen or not. Okay? So we're going to see how to figure that out. But it's going to be this one, and I'll show you in a second how you can be sure. And then on the other side is either this or this. Let's see, we're going to be up here, right? So it's going to be the one in the top. Now, if you want to be sure, here the question is, are we ever going to cross this horizontal asymptote? Because if it crosses, it could cross and then, this is what I'm saying. It could do this, cross and then come back down and get close like this. How do you know that this is not happening? Yes.
That can't happen because that would require it to cross the vertical asymptote.
No, why? The vertical asymptote is this one.
Sorry, I missed the horizontal asymptote.
What's the problem with that?
Well, there's no hole there, so there's no hole in the.
But horizontal asymptote are not a problem. You can cross horizontal asymptote. Like, look, here we are actually touching the horizontal. Okay, here we're doing this. But there will be examples in which, for example, you do this kind of stuff. So it will cross. Remember, horizontal asymptote is just what happens at the end, at infinity. What happens for the small values, anything can happen. You can cross, may not cross. So here what we want to say is, I will really always stay either on top all the time or below all the time the asymptote. So the question is, are we going to cross? Is this going to happen? It could happen. We're going to do an example, for example, in which this is going to happen. Look. And just close it here. Okay? We're going to do an example in which that, for example, if I didn't have this square over here, that sort of behavior was going to happen. Okay? We will still have the horizontal asymptote y equals 2. Well, it will be y equals 0, not y equals 2. But still, we're going to cross at 0. Okay? So, it could cross. Now, the thing is that rational functions are nice, so this kind of weird thing most likely is not going to happen. But how do you know for sure? Well, you ask the question. So the question is, will my function ever be equal to 2? Because that's what it means to cross this horizontal asymptote, right? Are we ever going to be equal to 2 with this function? So you solve the equation. So as 2x squared over x squared minus 4 equals 2, right? And then if we have a solution, then it crosses. If we don't have a solution, it doesn't cross. Well, let's see. This means that 2x squared is going to be equal to 2 times x squared minus 4. 2x squared is 2x squared minus 8. This guy cancel out, and then we get the statement 0 equals negative 8. What is this telling us? What does this mean? So this is false. So what can we say about this? It has no solution, which means that we're not going to cross. Okay? So f will not cross the line y equals 2. So now you know that it either will stay above or below, but it's never crossing. So now we are 100% sure that if we're already up here, then we need to stay above that line. So because there are no holes, no jumping, nothing, so we need to stay nicely like this. Similarly over here, we need to stay nicely on top, and here we need to stay nicely below. Okay? But this is how you can be 100% sure. Anyways, now with all of these little points and arrows, you should already see what the shape is. So now just do, a reasonable graph that matches all of that behavior. If you want more accuracy, then, you need to plot more points, but we're just sketching, so that's okay. We just do enough. Just make sure that you have at least 1 point on each piece, right? And then it's good enough. And then this one over here, we have this sort of behavior. And notice how this, even though we haven't talked about the notion of multiplicity, this is kind of respecting the multiplicity because locally around 0, okay, around 0, if you pick an interval around 0, all of these you can bound it by a number, so it's going to look like an x squared function. It just happens that this is going to be a negative number when you're very close to 0, and because of this guy, okay, it's going to be a negative number, and therefore it's going to look like negative x squared. So that's why you have this sort of shape. Okay, so there is also a notion of multiplicity, generalized version of multiplicity for rational functions, but we're not going to get into that. Okay, anyways, this is our graph. Questions? Do you understand this? Yes? Okay, so let's see. Before we take the break, let's do one more. How about this one? Try this one. So let's see, let's start finding all the information and then hopefully you'll be able to put the pictures together. So what's the first step that we need to do? Refactor everything. So nothing to do in the top, right? Can we do something in the bottom?
Yes.
Okay, how do we factor this? How do we factor it?
Just the answer.
X plus
Yeah.
3x minus 2.
X plus 3, x minus 2.
Wait, isn't
No, it's minus
X minus 3, x plus 2. Yeah, it's a negative one. X minus 3, x plus 2. Good. All right, questions? Are you okay with this? All right. Now, why factoring is helpful? Because factoring then allows you to figure out everything else rather quickly. Okay? So, domain, what are the values that we need to worry about? So, x cannot be 3, x cannot be negative 2. Okay? Everything else is fine. It works. Here is negative 3. Here is negative 2. Here is positive 3. You need to avoid those guys. The rest is okay. All right, so domain is down. Now, how about the intercepts? Do we have any x-intercepts?
It's 0,
0,0. Remember, it's very easy to figure out intercept for rational functions, just the zeros at the top. If you factor everything, just look at the zeros at the top. Okay? So in this case, that would be x equals 0, so that's a point 0, 0. Just make sure that this value is not one of the ones you're excluding, because it's not one of those, then that's a valid intercept. And then y-intercept is also the point 0, 0, right? Okay, so our function goes to the origin. All right, so after that, We need to simplify. Is there anything to simplify here? Nothing to simplify, so we move on. So now we look for asymptotes. Let's see, that's vertical asymptote, horizontal asymptote. Let's see, do we have vertical asymptotes?
We have, yeah,
What are they?
-2, 3.
So x equals 3, x equals -2. Remember, these are lines, okay?
And y equals 0.
Okay, a horizontal asymptote, we have one, which is y equals 0. All right, so use this information now to sketch. So remember, typically around the vertical asymptotes, you want to pick 2 points, one to the right, one to the left, so you can see where you should be going to positive or negative infinity, and so on, okay? So let's see, notice that in this example, we are crossing a horizontal asymptote, right? Because we have an x-intercept. The horizontal asymptote happens to be y equals 0, and we are going through it. But remember, horizontal asymptote is behavior at infinity. What happens when x is big in both directions? So when for small values of x, anything can happen. So it's okay to cross them. Like in this case, we're crossing. So do your x and y, draw the asymptotes first, the pair of vertical lines, the horizontal line, the x-axis. Then put the point, which is just 0, 0, and then start figuring out behavior around the asymptotes. Draw the asymptotes first, and then figure out behavior around the asymptotes. Put in some points. This has to be next. So for example, focus on one asymptote. Which one you want to analyze first? Now, so let's see to the right. Pick a number to the right. What will be a number to the right? Correct. 4. So plug 4 and see where you get positive or negative, and you will know if it goes up or down. And then keep on doing that to the other one on all the sides. so let's see. Remember, the first thing that you should do is draw your asymptotes, okay? So put our asymptotes and then worry about the rest. Okay, so x equal 3. Let's see, this is 1, so it'll be 1, 2, 3. So I have an asymptote here. And then x equals negative 2. Another one over here. Okay, so we have our vertical asymptotes, and then the horizontal asymptote happens to be y equals 0, which is the x-axis. So it stays there. So then plot all the points that you have. In this case, we only have 1 point, 0, 0. So there's some work to do. That's fine. Okay, so we have the point there. Let me have my little table here that is going to help us to get a more precise graph. So x, y, and then it's always good to label the type of point that you have. For example, we found 0, 0, and that's just our x-intercept, and it's also the y-intercept. The rest are going to be test points that we're going to use. So let's see. Behavior around the asymptotes, one at a time. So let's look at x equal 3. So again, is either this one or this one. Here you could just do a sign analysis to do it quicker, but anyways, we need a point over here. So there's nothing going on here. So we need at least 1 point to show that the function goes through. So we kill 2 birds with 1 stone. So we find the point and then we know the behavior. So let's see. I'm gonna pick 4 numbers to the right. Say that again. 2/3. Okay. So you plug it in. I trust you. 2 or 3. Okay. So 2/3. So that means this is somewhere over here. So this is 4. So we have this point. So what does that mean? Should we go up to positive infinity or negative infinity? Positive infinity, because the function is positive to the right of 3. And you can do a quick analysis. When x is bigger than 3, this is positive, and this is positive. Okay? So you need to stay positive. Okay, so on the other side, which one is it? So let's see, let's pick a 2. So what do we get? Negative 1/2. Okay, so that means here, negative 1/2. Right. Okay, so what does that mean? Is it going up to positive infinity or negative infinity? To the left? Is it going up or down? It's going down. So we have this behavior. Okay, to the right goes up, to the left goes down. Now move to this one and repeat. Let's see, to the right of negative 2. Is it going up or down? We can figure that out, let's say, by plugging in negative 1. So what happens if we plug in negative 1? If you put negative 1, what do we get? So it's going to be a negative 4. It's going to be a 1. So that will be negative 1 or negative 4. So that's 1 over 4, right? That's a quarter. So that's a quarter. By the way, all of these are test points. So a quarter, okay, so that's very tiny over here. Get this guy. But the point is that it's positive, so we're going to remain positive on this piece because there is no more x-intercept, nothing, okay? So we remain positive, so it has to go up. So it's not this one. And then on the other side, let's pick a negative 3. So if we put, you pick whatever you want. I'm just picking, the next thing that is in there. So when we put negative 3, what do we get? That's a negative 6 down here. That's a negative 1 here. So it will be positive 6. So negative 3 over 6, that's negative 1/2, right? So that would be negative 1/2. So it's right here. So that means it's going to go down. Why? Because if it was going to go up, it would need to go through the x-axis, but there's no more x-axis. Okay? So we need to stay down. And also, again, you can do a sign analysis. Here, if x is less than negative 2, this is going to be a negative, and a negative, because x is less than -2. So it's like -2 point something. So 3 negative. So the bottom is positive, negative divided by positive is negative. So we're good there. This is also a test point. Okay, so now we have the behavior around the vertical asymptote, and you just do this by putting points. That's all you have to do. It's really not the problem, right? Then let's figure out what happens. The horizontal asymptote. Let's see. What do you think is going to happen right now? In this one, when we go to positive infinity, are we above or below the x-axis? We have to be above because the function is already positive here, and there is no more x-intercept, so we need to stay on top. Do you understand this? The only way to go below is by going through the x-axis, and we cannot do that because we already have our x-intercept right here. And this one, which one is it? Above or below? As x approaches negative infinity. Below. Now with all these points and little arrows, you should be able to produce a picture, right? So for example, there is really one reasonable choice over here. Is something like this. And then similarly, there's one reasonable choice over here. This is something like this. Yes? And now what's going to happen in the middle? Between the two vertical asymptotes? We start from the top, then go down to the bottom, and we need to do a sort of cubic-like shape, right? So that's exactly what we do. Oops. Okay. Questions? Again, we're just sketching. If you want, something a little bit more precise, then you should probably plot more points here and so on. This gives you a general idea on how the graph looks like.